Okay, grade 9, this is your section 4.3 video on similar triangles using proportional reasoning or scale factor to solve missing sides of triangles. So question 6 is, are these triangles similar? And it gives you one triangle that is 2.5, 1.2, and 2.2, and another larger triangle that looks the same. So it's a 90-degree angle here, 90-degree angle here, and it says 12.5, 6, and 11. So it says, are these triangles similar? And another way they could have said that is they have R, S, and T here, and they have U, V, and W here. So another way to phrase that question, if I was giving you the question, I could say, how are these similar? Or I could put, is triangle RST similar to triangle UVW? This is the same question. Are these two similar? So really what it's asking you is, do you know what similar triangles share? And the first thing is they would share all the same angles. And here I know that they're going to be 90-degree angles. So I know that's for sure, but I don't know if the other two are the same, but I know that they look like they are, but we'll assume that the angles are equal. So the other thing similar triangles have is they have proportional side lengths, or side lengths that are increased or decreased by the same scale factor. So corresponding sides should all be increased or decreased by the same scale factor. So one way you can do it is to see what is the scale factor. So I'm going to pretend that this was my starting diagram, and I'm going to put an A above it, and I'm going to put a D above this triangle to show that's the diagram I made. Because in this case, there are no missing side lengths, and it doesn't matter which one we choose. So I usually like to gravitate to a enlargement, which means my scale factor will be larger than 1. So I'll be multiplying the side lengths of this one by a number that is greater than 1, because I'm going to make this one, which is an enlargement, if it is, in fact, similar triangles. So scale factor is determined by taking the diagram and dividing it by the actual. So since I've defined this triangle as the diagram, I'm going to make the hypotenuse the D. Now, if this is the same scale factor, its corresponding side length will be 2.5. And 12 divided by 2.5 is 5, but I'll just grab my calculator to show you. Oh, it's over here. So 12.5 divided by 2.5 equals 5, which means the scale factor, I multiplied my actual side by to get its corresponding side, was 5. Now, if every side and its corresponding side is multiplied by 5, if this times 5 is 6 and this times 5 is 11, then we are okay. Then it is a proportional thing. So 1.2 times 5 is 6. 1.2 times 5 is 6. And the other side was 2.2. So 2.2 times 5 is 11. And therefore, we can say, yes, they are similar. Okay, because all of their sides are proportional to the corresponding sides. Question 8 is too long and wordy. I'm not going to bother doing it, and you're not going to have it on your test, so don't worry about it. Question 9, it says triangle STR is similar to triangle UWV. Determine the missing side length. So it gives you this triangle here, and it said this is STR. And the side lengths for this triangle are 8, 10.5, and 10.5. And then it gives you another one pointed in the different direction. It says this is X, this is 73.5, and this is 73.5. So really, this is an isosceles triangle, and this is an isosceles triangle. So because they're similar, the ratio or the proportion that would be created between those two will be proportional to those two. So there's two ways we can solve it. The first way is to determine the scale factor. So this is going to be my actual triangle, and the reason why this is my actual triangle is because I know all three sides. This is going to be the diagram because I don't know all three sides. There's an X here that I don't know. And I'm going to say, all right, so D divided by A will give me my scale factor, or 73.5 divided by its corresponding side, which is 10.5, will tell me the scale factor. 73.5 divided by 10.5 is 7. So that means the scale factor I used for my actual to create this was multiplying this by 7 to create this one, this by 7 to create this one, and therefore this times 7 will create this one, and 8 times 7 is 56. So that's the first way you can solve it, is by determining scale factor. The second way you can determine it is to set up a proportion. And for this one, I better label these. This is UVW here. So if I set up a proportion, the proportion of SR, so I'm going to go the small, I'm just going to call it small to big, or original, or actually, no, I'm not going to call it small to big. I'm going to call it the actual diagram to the diagram. So the ratio of SR to UV, or this side to this side, the ratio of those two sides is proportional to this side, which is ST, over UW. So when I define the lines by the points, so this is SR here, and this is UV here, I could set it up with words saying the ratio of SR to UV will be proportional to ST to UW. And when I substitute my numbers into that, SR is 10.5 to 73.5 will be proportional to 8 over X, because UW is X and ST is 8. When I solve it with algebra by cross multiplying, I get 10.5X will equal 560, 584, 584 plus 4 is 588. Divide both sides by 10.5. And it should be the same answer as we got before. 588 divided by 10.5 is 56. So X equals 56 using proportional reasoning. Okay, question number 10. So here we have a setup where two triangles are determined to be similar, and here's why they are. So if I look at this triangle, I'm going to trace it in green, this triangle here. Okay, I know that this angle here and this angle are the same because when two intersecting lines meet, their opposite angles are going to be the same degree. I also know that this green triangle has a 90-degree angle, and its other one over here has a 90-degree angle. So let's pretend this was 20 degrees and this was 20 degrees. So right now, this triangle has a 90-degree angle, a 20-degree angle, and this one up here must be 70 degrees. And this has a 90-degree angle, a 20-degree angle, and this one must have be 70 degrees. So right off the bat that we know they're similar triangles because they have three angles that are all the same measure. So we know they are going to be similar triangles. Now the other part is, what are their corresponding sides? So for some people, they have a hard time determining what the corresponding sides are, and I'll show you an easy way to do it. So if I take this triangle and rotate it, and then put it back up here, there's our corresponding sides, right? That's one way to do it. You could do it that way. Another way to do it, to determine corresponding sides, oh, come on now, please, Lord. Here we go. Another way to do it, which is even easier, is to realize that this side here is a hypotenuse, and this side here is a hypotenuse, so they are going to be corresponding sides. So if I take this one as being my actual, because I know all three sides, and I take this one as being my diagram because I'm missing a side, then I can use scale factor. So diagram divided by actual will be 12.5 divided by 22.5, because my D hypotenuse is 12.5 and my A hypotenuse is 22.5. Grab my calculator. I think this is a repeating decimal if I'm not mistaken. Is 0.5 repeating? So your scale factor that you multiplied both by 0.5 repeating, or if you want to use fractions, 5/9. because 5/9, if I go to a calculator and say what's 5 divided by 9, it's the same number. So you can either use the fraction as your scale factor or the repeating decimal as your scale factor, and either way works. So now that this is true, then this was multiplied by 0.5 repeating to get its corresponding. Okay, so because I multiplied this side by 0.5 repeating, in order to find this side here, I'm going to have to multiply this by 0.5 repeating. Or if I don't have a calculator, 18 multiplied by, remember I told you this here? So 18 over 1 multiplied by 5 over 9, which is what 0.5 repeating is not a hard fraction question, because when I cross-reduce that, I get 2 over 1, which is going to give me the answer of 10, right? If I use fractions instead of decimals. Now, if I use decimals, I have to take my calculator and go decimal 5 until it won't let me put any more in. Oh, wow, this is kind of multiplied by 12.5. I made a mistake, didn't I? What was it supposed to be? Oh, multiplied by 18. Oh, sugar cubes. Oh, no, what's going on? Anyway, so 18 multiplied by decimal 5 repeating equals 9.9 repeating, which we know is 10. So therefore, the answer is x is 10. Question number 12. So Sam built a ramp. So there's his ramp. And he put a support beam of 1.2 meters right here. So this is at 90-degree angles, and this is at 90-degree angles. And the distance from this edge of his ramp to the support beam is 3 meters. And the distance from his support beam to the other wall is 2 meters. And it says, how high is the loading dock? Okay, so X, how high? So this is the loading dock here where people are standing. How high is this loading dock? So in order to solve this, when you have composite figures that have more than one triangle, like I told you yesterday, my recommendation is you redraw them. So put this one over here. Put this one over here. And now I have two triangles. And I'm going to extend the page. Oh, no. Heavens to Betsy. Oh, no. Oh, heavens. Oh, no. All right, forget it. We'll just do it up here. We're just going to do it right up here. Okay, so now we have our drawing recalibrated here. So what I'm going to do is put the measurements I know. So 3 goes here, because that's the distance from here to here, that small triangle, and 1.2 goes here. Now there's only one thing that most students get wrong, and that's the length of this line right here. Some people put down 2, but clearly the line of that whole line is the sum of 3 and 2, which makes it 5, and makes this x. So if I figure out, if I want to assign something, since I know both of these, this is going to be my actual. Since I'm missing one of these, I'm going to call it my diagram. Scale factor, d divided by a to get your scale factor. Or 5 divided by 3 is my scale factor. 5 divided by 3 is 1.6 repeating, or 1 2/3. So that's my scale factor. So if I multiply this by 1.6 repeating, am I wrong with that? Did I make a mistake? So 1.2 multiplied by 1.6 repeating. So much fun. Equals 1.9 repeating, which of course we know is 2. And therefore, the height of the dock is 2 meters. Now again, if you wanted to multiply 1 2/10 by 1.6 repeating, 0.6 repeating is 2/3. So this question here, as a fraction, if you didn't have a calculator, is really this, which is 12/10 multiplied by 5/3. Right, cross reduce, you get 4 over 1. Cross reduce, you get 1 over 2. Top reduce, you get 2 over 1. Either way, you still get the answer of 2. Oh, that's not right. Next page, new page. We're going to do one more, and then we'll call her a day. Let's do you want to do 13 or 14? Let's do 13. We'll do 13. So here's a wall. And there is two ladders leaned up against it. There's an 8-meter ladder, and there is a 3-meter ladder lined up against it. Okay. The 3-meter ladder is able to go up 2.4 meters on this wall. The question is, how high up can the 8-meter ladder go? So, Alyssa says we should make two triangles. So I'm going to draw this one here, and I'm going to drag it down here. And I'm going to make this one here, and I'm going to drag it down here. So in my small triangle, I know this is 3, and this is 2.4. And in my large triangle, I know this is 8, and I know this is x, but it's not actually x. It's x with a little bit more information. We're going to call this distance here x. Okay? So I'm not going to call the whole thing x. I'm going to call this distance x. Okay? So the whole distance here is not just x. It's going to be x plus an additional 2.4. Okay? So this is going to be 3. This is going to be 2.4. This is going to be 8. This is going to be x plus 2.4. So what we're going to do here is we're going to solve it by we're going to use proportional reasoning this time. We're going to set it up as a proportion. So 3 to 8. So this side to this side is going to be proportional to this side to this side, or 2.4 over x plus 2.4. Okay, so we're going to set up as a proportion like this. Now the only difference between this and a normal question is normally when we set up as a proportion we just have an x there, and we would multiply to get 3x. But because we have x plus 2.4, when we multiply across the equal sign in our proportion, we are going to be multiplying a binomial by 3, which means we have to use distributive property. So on one side of it, I'm going to get 3 times x plus 2.4 is equal to 16 plus 3.2, 19.2. So the only difference between these two is I'm going to create an algebra question that has distributive property. Now if I expand, I'm going to get 3x plus 7.2 equals 19.2. Subtract 7.2 from both sides. I get 3x equals 12. Divide by 3, and x will equal 4. Now remember, we're not solving it yet. X is just 4. So when I put 4 here, that's the distance from here to here, which means the whole distance is the sum of 4 and 2.4, which makes the 8-meter ladder able to reach up 6.4 meters.